Hi, this video is about the Caribou Mathematics Contest. I'm going to show the solution for the April 2015 Grade 11-12 Contest, question 14. So the question is, the sum of the first two terms of a geometric sequence is 20. The sum of the second and third term is 30. How many terms of the infinite sequence are integers? Hint, in a geometric sequence, each number is obtained by multiplying the previous number with one and the same constant. So as a reminder, the arithmetic and geometric sequences are shown here on the board. Alright, so let's take a look at the arithmetic sequence first. So each term is calculated by adding one and the same number to the previous term. So for example, we would have A, and then next we would just add one in the same number, so here it's B, and then we have A, and then A plus B, A plus 2B, next would be A plus 3B, and so on. And in the geometric sequence, it is the exact same thing. Instead of adding the same number, one in the same number to the previous term, you are multiplying one in the same number to the previous term. So instead of adding a B, here we are multiplying B. So first we obviously start off with A times B, A times B squared, and then next would be A times B cubed, and so on. Alright, but in this question, all we are using is the geometric sequence. We don't need the arithmetic sequence at all. Alright, so now looking at the question again, it says the sum of the first two terms of a geometric sequence is 20. Alright, so that would be A plus A times B would be equal to 20. But now we can see that they both have a factor of A, so using the distributive law, factor out A, then we have just 1, and then here we have just the B. And we know that that is equal to 20, as shown on the board. Alright, next we know the sum of the second and third term is 30. So the second term is A times B, and that is plus A times B squared, alright, and now we have A times B in both factors, so we can use the distributive law again. Then we have A, B, then we just have 1 plus B. And that is equal to 30. Alright, now we can see if we divide this by that, all we would have left is B, because the 1 plus B both cancel out and the A also cancels out. So if we do that, then we will be left with just B equals 2, and then we would have 30 over 20, which simplified is just 3 over 2. Alright, so now to find A, we will just substitute 3 over 2 into here for B. So we have 1 plus 3 over 2 is 5 over 2. So now we would have 5 over 2A equals to 20. So we'll write that over here. Alright, and now obviously we just want the A on one side. So we have to divide both sides by 5 over 2, or just multiply 20 by 2 over 5. So first we'll do 20 divided by 5 is 4, and then times the 2 is then 8. So A is equal to 8. Alright, so here's the geometric sequence, and let's write maybe the first 5 or 6 terms. Alright, so first we have A, and we know that is just 8. Next we have A times B, so we would have 8 times 3 over 2. But now we're not interested in the value of each term. We're interested if that is an integer or not, because from the question we want to know how many terms of this infinite sequence are integers. So we want to get rid of the denominator as long as possible. So now we will always just multiply by 3, because it's 3 squared, and we will always divide by 2. So if we divide this by 2, 8 divided by 2 is 4, and multiply by 3, we have 4 times 3. And we can see that is an integer. Alright, so next we have a times b squared. So again, we're just going to divide by 2. 4 divided by 2 is 2, and multiply by 3. So instead of just 3, we have now 3 squared. Okay, next, now we're going to divide by 2 again. So then we have just 1 times, and then multiplied by 3 again is 3 cubed. And now next, we're going to divide by 2 again and multiply by 3. Well, we have nothing else to divide by 2, so if we multiply by 3, we get 3 to the power of 4. And now we would have to divide by 2. And now we can see that this will always continue for all the next infinite terms, that there will always be a denominator, and therefore all the rest terms will not be integers, because it will always multiply by 3, and the denominator will always add by a factor of 2. So now we can see there are 1, 2, 3, 4 integers in this infinite sequence. So the answer is option B, 4. If you'd like to know more about this contest, please feel free to visit our website at cariboutest.com.